In the summer of 2020, farmers across southern China watched the sky turn dark in the middle of the day. It wasn't a storm cloud. It was a swarm, millions of locusts moving as one single organism, blotting out the sun over fields that had taken families generations to build. Crops that were weeks away from harvest disappeared in hours. Entire villages watched years of work vanish under a moving carpet of insects that seemed impossible to stop. Locust swarms have haunted farmers since the beginning of agriculture itself. Ancient texts from every corner of the world describe them as a curse, a plague, a punishment from the heavens. And for most of human history, there was almost nothing anyone could do. You could burn fields, dig trenches, light fires, and pray. None of it really worked. The locusts always came back, and when they did, they took everything. But in parts of China, something strange started happening. Farmers who once stood helpless against these swarms began fighting back with a method so unexpected that when foreign agricultural experts first heard about it, they assumed it was a joke. It wasn't pesticide. It wasn't some new chemical weapon developed in a lab. It was ducks. Tens of thousands of ducks, marching across farmland in tightly coordinated formations, devouring locusts by the millions before the swarms ever had the chance to destroy a single crop. This is the story of how a country facing one of nature's oldest and most devastating threats found a solution that was equal parts ancient wisdom and modern military-style logistics. It involves biologists, drones, an army of poultry, and a level of coordination that turned pest control into something that looks more like a national defense operation than a farming technique. But to understand why China turned to ducks of all things, you first need to understand just how terrifying a locust swarm actually is. A single locust isn't much to worry about. It's a grasshopper, essentially, a small insect that eats plants and hops around fields doing minimal damage. But locusts have a strange and horrifying biological switch buried in their DNA. When locust populations reach a certain density, when there are enough of them crowded together in one place, something changes inside their bodies. They begin to transform. Their brains release extra serotonin. Their bodies change color, often turning a deeper yellow or black. Their behavior shifts from solitary and shy to social and aggressive. This is called the gregarious phase, and it turns ordinary grasshoppers into something closer to a coordinated army. Once locusts enter this phase, they don't just tolerate being close to each other, they actively seek each other out. They begin moving in the same direction, feeding together, breeding together, and eventually taking flight together. A single swarm can contain literally billions of individual insects. Some of the largest swarms ever recorded have stretched across hundreds of square kilometers, containing enough insects to eat their combined body weight in vegetation every single day. When you multiply that math out, a swarm that size can consume enough food in 24 hours to feed tens of thousands of people for an entire year. What makes this transformation so unsettling is how quickly it can happen. A field that looks perfectly normal one week can be crawling with gregarious phase locusts the next, and within days those insects can take to the air as a unified swarm, capable of traveling over 100 kilometers in a single day, carried along by wind currents that they seem to almost cooperate with rather than fight against. Scientists who study this behavior describe it as one of the most dramatic examples of environmental triggers rewriting an animal's biology in real time. The same genetic code that produces a shy, solitary grasshopper can, under the right conditions, produce a member of a devastating airborne horde, and there's very little that separates the two states beyond population density and a handful of chemical signals. For farmers, this isn't an abstract statistic, it's an existential threat. A swarm can descend on a field of wheat or corn in the morning and leave nothing but stripped stalks by the afternoon. There's no reasoning with it, no fighting it in any conventional sense. Locusts don't attack one farm and move on politely. They keep eating until the food runs out, and then they keep flying until they find more. China has dealt with locust plagues for thousands of years. Ancient records dating back over 3,000 years describe locust invasions, destroying harvests and triggering famines. Emperors organized armies of soldiers and villagers to dig trenches, light fires, and physically beat the ground trying to kill locusts before they could take flight. None of it worked particularly well. The insects reproduced faster than anyone could kill them, and the swarms often returned within weeks, sometimes stronger than before. Historical dynasties even built entire bureaucratic systems around locust management, with officials tasked specifically with tracking outbreaks and reporting them up the chain of command. Some emperors offered rewards to villagers who collected the most dead locusts, essentially turning entire regions into makeshift extermination workforces during outbreak years. Temples were built specifically to pray for protection against swarms, and historical chronicles often link the fall of entire dynasties to the famines that followed particularly devastating locust years. This wasn't a minor agricultural nuisance. It was a recurring national catastrophe that shaped the course of Chinese history for centuries. For most of the 20th century, the primary weapon against locusts was chemical pesticide, sprayed from planes or trucks across massive stretches of farmland. And to be fair, pesticides do kill locusts, but they come with serious problems. Chemical spraying is expensive, especially across the enormous rural areas where swarms tend to originate. It requires specialized aircraft, trained pilots, and constant resupply of chemicals that need to be manufactured and transported to remote regions. It also poisons the soil, kills beneficial insects like bees, and can contaminate water supplies that local communities depend on. In regions where farming is already a fragile, subsistence-level activity, the cost of aerial pesticide campaigns can be almost as devastating as the locusts themselves. There was also a deeper problem. Pesticides only work after locusts have already gathered into dangerous swarms. By the time a swarm is large enough to spot from the air and spray effectively, it has often already caused significant damage. Farmers needed something that could catch locust populations early, before they transformed into the gregarious, crop-destroying phase. They needed a solution that could operate continuously, cheaply, and without poisoning the very land they depended on. That's when officials in certain provinces started looking back at an old idea that had mostly been forgotten. For centuries, some Chinese farmers had used ducks to control insect pests in rice paddies. Ducks are natural foragers. They wade through wet fields, snapping up insects, snails, and larvae as they go. It was a technique passed down through generations, mostly used on a small scale. A handful of ducks wandering around a single family's rice paddy, eating whatever pests happened to be around. Nobody had ever really scaled this up before. Nobody had ever asked the question, what if you used ducks not just to protect a small paddy, but as an actual weapon against a national locust threat? The idea sounds almost too simple to work. But agricultural researchers in China took it seriously enough to actually test it scientifically. And what they found was staggering. A chicken, it turns out, can eat around 70 locusts a day. Ducks, however, are far more efficient hunters. A single duck can consume somewhere between 200 and 300 locusts in a single day. That's not a typo. Ducks are essentially living, breathing, self-replicating pest control machines. They don't need fuel. They don't need chemical manufacturing plants. They reproduce on their own. They're relatively cheap to raise, and unlike pesticide, they leave behind fertilizer instead of poison. Researchers also discovered something else interesting during their early trials. Ducks seemed to actively hunt locusts with more enthusiasm than almost any other pest they were fed. It wasn't just about calories. Something about the way locusts moved, low to the ground and slow compared to flying insects, made them almost perfectly suited to a duck's natural foraging style. Handlers running early tests noted that ducks would chase locusts across open ground with a kind of focused aggression, rarely seen when the birds foraged for other food sources, snapping them up almost as fast as they could hop away. Once researchers confirmed how effective ducks were at destroying locust populations, the next challenge was figuring out how to deploy them at a scale large enough to actually matter. This is where the story stops sounding like traditional farming and starts sounding like a full-blown military logistics operation. In 2000, China faced one of its worst locust outbreaks in decades. Provinces in the north and west, particularly in areas near Xinjiang, were being hit by swarms so large that conventional pest control methods were struggling to keep up. That's when officials made a decision that seemed almost absurd on paper. They deployed an army of 30,000 ducks directly into the affected farmland. Picture that for a moment. 30,000 ducks, transported by truck to the edges of locust-infested fields, then released in coordinated waves to march across the land, eating everything in their path. It wasn't random. It was organized with the kind of precision usually reserved for actual military deployments. Handlers moved the ducks in disciplined formations, directing them toward the densest locust populations first, then rotating them through different sections of farmland as the insects were cleared out. The results were immediate and dramatic. Within days, locust populations in the targeted areas had dropped by staggering margins. Fields that would have taken weeks of aerial pesticide spraying to treat were cleared by ducks in a fraction of the time, at a fraction of the cost, and without a single drop of chemical poison touching the soil. Word of the success spread quickly through China's agricultural community. What started as an experimental deployment in one region became a nationwide strategy. Provinces began training and organizing their own duck armies specifically for locust control. Some regions built entire breeding programs dedicated to raising ducks, specifically for pest control deployment, treating it as seriously as raising crops or livestock for food. The logistics behind this became increasingly sophisticated over time. Local governments began working with agricultural universities to study the most efficient duck breeds for the job, looking at factors like how quickly the birds could move across different types of terrain, how much locust matter they could consume relative to their body size, and how quickly they could be transported and deployed when a new swarm was detected. Certain breeds turned out to outperform others by a wide margin. Campbell ducks and a few specially bred hybrid lines showed particular promise, combining fast movement across rough terrain with an appetite that seemed almost tailor-made for the job. Universities began running breeding trials specifically designed to produce ducks that matured quickly, tolerated long-distance transport without stress, and maintained their appetite for locusts even after repeated deployments. Within a few years, some regions had developed what amounted to specialized locust-hunting duck lineages, bred and raised specifically for this single purpose, rather than for meat or egg production. Transportation became its own science. Moving tens of thousands of ducks isn't as simple as loading up a few trucks. Handlers developed specialized carrying crates that could be stacked efficiently, allowing convoys of trucks to move massive numbers of birds hundreds of kilometers to reach outbreak zones. Teams learned to time deployments around the birds' natural feeding rhythms, releasing them at dawn when locusts were most active and easiest to catch before they had fully warmed up and become airborne. The ducks themselves needed careful management once they were in the field. Unlike pesticide, which can simply be sprayed and left to do its work, a duck army requires active herding and direction. Handlers on foot, sometimes assisted by trained dogs, would guide massive formations of ducks across farmland, making sure they covered ground systematically rather than wandering aimlessly. It required patience, skill, and an intimate understanding of both the bird's behavior and the movement patterns of the locusts they were hunting. Some handlers developed almost a sixth sense for reading the birds. Experienced duck herders could tell within minutes whether a formation was moving efficiently or wasting time, and they would adjust their whistles, calls, and hand signals to redirect thousands of birds at once. It's a skill that takes years to develop, closer to shepherding than anything most people would associate with poultry farming. Some of these handlers became local celebrities in their communities, known for their uncanny ability to command an army of ducks across a field like a general directing troops. Here's where the story takes an unexpected turn toward the future. As successful as the duck armies were, officials realized there was still a major weakness in the system. Ducks are incredibly effective at eating locusts once a swarm has already formed and gathered in a specific location. But locating swarms early, before they grew into unmanageable sizes, remained a challenge. Locust populations often begin building in remote, hard-to-monitor regions, sometimes in areas so isolated that human observers simply couldn't get there fast enough to spot the danger before it escalated. This is where China's rapid advancement in drone technology started intersecting with the ancient practice of duck-based pest control. Agricultural monitoring stations began deploying surveillance drones equipped with cameras and sensors specifically designed to detect the early stages of locust population growth. These drones could cover vast stretches of remote farmland and grassland far faster than any human patrol on foot or by vehicle, spotting the telltale signs of gregarious phase locusts gathering in dangerous numbers. Once a drone identified a developing threat, that information would get relayed to regional agricultural command centers, essentially operations rooms dedicated entirely to pest management. From there, officials could make a rapid decision about how to respond. If the population was still small enough, targeted duck deployments could be arranged and transported to the exact coordinates identified by the drone survey, hitting the threat before it ever had the chance to grow into a full swarm. This combination of ancient biological pest control and cutting-edge surveillance technology created something genuinely unprecedented. It wasn't just about reacting to locust swarms anymore. It became a proactive system, one that could identify threats in their earliest stages and neutralize them using an army of birds that cost almost nothing to maintain compared to chemical alternatives. The economic implications of this system are enormous when you actually break down the numbers. Aerial pesticide campaigns require constant chemical resupply, specialized aircraft maintenance, trained pilots, and fuel costs that scale directly with the size of the affected area. A duck, by comparison, is a one-time investment that continues working for years, reproduces on its own, and actually generates additional value through its eggs and meat when it's not being deployed for pest control duty. Provinces that adopted large-scale duck deployment programs found that their overall pest control budgets dropped significantly compared to regions still relying primarily on chemical spraying. The ducks essentially paid for themselves multiple times over, both through the crops they saved and the agricultural products they produced during periods when there wasn't an active locust threat to manage. Local officials also noted a shift in how communities viewed pest control spending. Instead of watching tax money get spent on chemicals that vanished after a single use, residents could see their duck flocks growing year over year, becoming a visible, tangible community asset rather than a recurring expense. Some villages began treating their duck flocks almost like public infrastructure, something to be maintained and protected collectively, rather than viewed as a disposable government program. There's also an environmental dimension to this story that's easy to overlook. Chemical pesticides don't just kill locusts, they kill beneficial insects too, disrupting local ecosystems in ways that can take years to fully recover from. Bee populations, which are critical for pollinating crops beyond just the ones threatened by locusts, are particularly vulnerable to pesticide exposure. Waterways near heavily sprayed farmland often show elevated levels of chemical runoff, affecting fish populations and the broader food chain. Ducks, on the other hand, integrate naturally into the existing ecosystem. They eat locusts and other harmful insects, but they don't poison the soil or water. Their waste actually acts as a natural fertilizer, improving soil quality in the very fields they're deployed to protect. Farmers in regions that adopted duck-based pest control began noticing secondary benefits beyond just locust suppression, including healthier soil and reduced need for chemical fertilizer in subsequent growing seasons. The success of this program didn't go unnoticed internationally. Agricultural researchers from other countries facing their own locust problems began studying China's duck deployment strategy with genuine interest. East African nations, which have battled some of the most devastating locust outbreaks in modern history, particularly during the massive 2019 and 2020 swarms that devastated crops across Kenya, Ethiopia, and Somalia, sent delegations to study how China's system actually worked in practice. There were, of course, challenges in trying to export this model to other regions. China's duck deployment strategy relies on decades of accumulated infrastructure, breeding programs, trained handlers, and logistics networks that took years to build. It's not something you can simply replicate overnight by shipping a few thousand ducks to a new country and hoping for the best. The birds need specific climate conditions, access to water sources, and trained personnel who understand how to direct them effectively across unfamiliar terrain. Still, the core principle behind the strategy, using natural predators as a scalable, sustainable alternative to chemical pesticide, has influenced pest management thinking well beyond China's borders. Some African nations have begun experimenting with their own versions of biological pest control, incorporating birds and other natural locust predators into their broader anti-swarm strategies, even if the scale doesn't yet match what China has achieved. Back within China itself, the program has continued to evolve. Researchers have expanded beyond just standard domestic ducks, studying other bird species that might be even more effective at locust suppression in different climates and terrains. Some regions have experimented with combining duck deployment with other natural predators, including certain species of birds that naturally prey on locusts in the wild, creating a more diverse ecological approach to pest management rather than relying on a single species. The drone surveillance component has also grown increasingly sophisticated. Modern systems now incorporate satellite data alongside drone footage, allowing agricultural monitoring centers to track weather patterns, soil moisture, and vegetation growth across enormous swaths of territory. Locust outbreaks tend to follow predictable environmental triggers, often correlating with specific rainfall patterns that create ideal breeding conditions. By combining this environmental data with real-time drone surveillance, officials can now often predict where and when locust populations are likely to begin transforming into the dangerous gregarious phase, sometimes weeks before an actual outbreak occurs. This predictive capability represents perhaps the most significant advancement in the entire system. Rather than simply reacting to swarms after they've already formed, or even catching them in their early stages through drone detection, officials can now pre-position duck deployment teams in regions identified as high risk, ready to respond the moment conditions indicate a population boom is beginning. Some provinces have gone even further, establishing what are essentially standing duck reserves stationed near historically vulnerable farmland, ready to be mobilized within hours rather than days. These reserve flocks are rotated regularly to keep them healthy and battle-ready, and handlers run periodic training exercises to keep the birds accustomed to rapid transport and deployment. It's an approach that mirrors military reserve forces more than anything typically associated with agriculture, and it reflects just how seriously the country has come to take this unconventional weapon against locust swarms. Local schools in some of these regions have even started incorporating the duck program into agricultural education, teaching children about the biology behind locust swarms and the ecological reasoning that makes duck deployment such an effective countermeasure. Younger generations growing up in these farming communities are being raised with a completely different relationship to the locust threat than their grandparents had. Instead of stories of helplessness and famine, they're learning about drones, breeding science, and coordinated response teams, absorbing the idea that even nature's oldest threats can be managed with the right combination of biology and technology. Tourism has even sprung up around some of the more visually striking duck deployments, with visitors traveling from nearby cities just to watch thousands of birds move across a field in unison, a spectacle that's become something of a minor cultural attraction in certain rural counties. The scale of this operation today is genuinely staggering when you consider how it started. What began as a desperate experimental measure during a single severe outbreak in 2000 has grown into a nationwide, technologically integrated pest management system involving hundreds of thousands of trained ducks, sophisticated drone surveillance networks, satellite monitoring, and dedicated agricultural command centers coordinating it all. Farmers who once watched helplessly as swarms destroyed their crops now have access to a rapid response system that can identify and neutralize threats before they ever reach the scale that devastated communities for generations. The psychological shift this has created within farming communities is significant too. Locusts were once viewed as an unstoppable natural disaster, something farmers simply had to endure and hope to survive. Now they're viewed as a manageable threat, one that can be detected early and dealt with efficiently using a combination of ancient wisdom and modern technology. There's something almost poetic about the fact that the solution to one of agriculture's oldest problems turned out to be another form of agriculture entirely. Instead of fighting nature with chemicals manufactured in industrial facilities, China essentially recruited nature itself to fight back. Ducks, an animal humans have raised for food and eggs for thousands of years, became soldiers in a war against another ancient agricultural enemy. The system isn't perfect, and it isn't a complete replacement for all forms of pest control. There are still situations where chemical intervention remains necessary, particularly in cases where swarms grow faster than duck deployment logistics can respond, or in terrain where moving large numbers of birds simply isn't practical. But as one tool within a broader pest management strategy, the duck program has fundamentally changed how China approaches locust threats. It also raises interesting questions about the future of pest control more broadly. As climate change continues to alter weather patterns around the world, many scientists expect locust outbreaks to become more frequent and severe in various regions, as changing rainfall patterns create more opportunities for the population booms that trigger the gregarious phase transformation. Countries that develop effective, sustainable, and scalable responses to this threat may find themselves significantly better positioned to protect their agricultural output compared to nations still relying primarily on expensive, environmentally damaging chemical solutions. China's experience suggests that sometimes the most effective solutions to modern problems aren't found in laboratories developing new chemical compounds, but in looking back at traditional practices and asking whether they could be scaled up using modern logistics and technology. The duck armies that march across Chinese farmland today aren't just a quirky footnote in agricultural history. They represent a genuinely innovative approach to pest management that combines biological efficiency with technological precision in a way that few other countries have managed to replicate. Whether other nations will be able to successfully adopt similar strategies remains to be seen. The infrastructure, breeding expertise, and logistical coordination required to run a program at this scale took China years to develop, and simply importing ducks to a new country won't automatically recreate the same success. But the underlying principle, that nature often already contains the tools needed to solve problems that seem to require complex technological interventions, is a lesson that extends far beyond just locust control. For now, the fields of China continue to be protected by an unlikely army. Thousands of ducks, coordinated through drone surveillance and satellite data, marching across farmland in disciplined formations, eating their way through one of nature's most destructive forces. It's a strange sight if you've never seen it before. Waves of white and brown birds moving methodically across a field. But for farmers who once had no defense against locust swarms, it's become one of the most reassuring sights in modern agriculture. The next time a swarm begins forming somewhere in a remote corner of Chinese farmland, there's a good chance a drone will spot it first, and an army of ducks will be there to answer the call, doing what their ancestors have done for centuries, just on a scale nobody could have imagined before. And in a world where the old threats of famine and crop destruction never truly go away, that combination of old wisdom and new technology might be exactly the kind of solution more countries need to start taking seriously.